Hello, and welcome to Friday edition of Spindle TV. These storms in Florida here, they're crazy. It's storming bad now, but I was like, there's no way I'm not doing it. There's no way I'm not having a class tonight after postponing last night, and we'll just let the lightning rumble and see how far we can get before the power goes out. But it is what it is. How's everybody doing tonight? We are going to see if we can get into a little bit more on talking about the design of this poker table. We're going to make a couple of the parts and kind of lay out some of the parts so you can see, how those can be approached. And then when it's all said and done, I'm going to put together a PDF document with some measurements, sizes, instructions, and everything like that, that if someone wanted to make a poker table, they would be able to. All right, with that being said, let's go ahead and take a look at the design and where we're at. And welcome, everybody. Thanks for joining in tonight on this Friday night. Let's talk about the design. Let's switch places here. And the poker table is, let me get this kind of view here. Bear with me just a second. The poker table itself, from the outside of the trim to the outside of the trim on its short flats areas and everything, we're about 4 foot, so 48, 52 and 3/4 inches altogether, about 52 inches wide, 52 and 3/4 inches wide. And it's an 8-sided octagon table. As you can see here, I changed up the sides. So after our last class, someone had commented in the comments section. They said, Laney, why aren't you putting the cup holders on the seams so that way it could work for either a left-handed or a right-handed person? And then, that would give more room and everything for the card area. And I went back and I went and looked at it again, and I thought, you know what? Why not? Why am I not doing that and everything? So the area on the seams are cut out on the parts and everything for the cup holders and all. So it will accommodate for a left-hand or right-hand person. On the coin or the chip holder and card area and everything, let me get lined up here. I'm not lined up. Move, line that up. Ooh. I've separated them now, spread them out. Got 2 rows on the right, 2 rows on the left, and then kind of a flat open area in the middle. If, for whatever, gameplay card area, whatever you want. You can play on the field, or you can, in here. The I'm thinking for the, the material and all, I saw a really nice, not this old house, the New Yankee Workshop. They had a poker table build on the New Yankee Workshop, and they did a mahogany table. Now it was mahogany. There was some hardwood mahogany, but then it was plywood mahogany, and then it was, stained and stuff on top of that, and it looked really good. It was a good looking color and everything. And so I was thinking about something like that, but I want kind of a contrast going on here. So I think the trays themselves, they're going to end up being inlaid into a pocket area and everything. They're going to kind of be inlaid in to the pocket area and stuff, to give a little bit of a contrasting color. And as far as wood selection, I haven't decided on that yet. I do know that the center area is either going to be plywood or MDF. Either one will be fine. It's going to have a thin foam style cushion. We talked about that last time. There's going to be kind of a foam style cushion. You get this, in rolls over at Joint Fabrics. And then there's going to be, of course, the play area felt. And it just gives a little bit of padding and everything, in that game area and stuff. Now, the felt in that cushion area is getting wrapped around a piece of 3/4 inch, either MDF or plywood, your choice. And sorry, guys, if y'all see my hands kind of beat up. I was working out in the yard on the property, and bougainvillea bush, they got big old thorns. It tore me up from the floor up, boy. It kicked my butt. But it won the battle on that little escapade. But so either 3/4 inch plywood or MDF, either one, it doesn't matter at that point. Now, let me hide this for a second. Let me hide these three things just so I can come in here. There is going to be an apron that is going to be applied. It's 2 inches wide, 3/4 inches thick, and that's going to be rabbited in, or it could be butt joint in, like I have it here in the drawing. Either one to, underneath those pieces. And then we're going to have a trim. Let me see if I can move this whole thing for right now. We're going to have a trim that has, let's see if I can get the profile there, has a nice little curved profile, and it's going to trim off that whole joint here and everything. And also I was holding the control key down when I moved that, so I don't need to hold the control key down. So that joint area where the top and the sides join together, the apron, the top and the apron and all, this trim is going to trim it off to finish it off and everything. So that's going to be, that's going to be the kind of upper area. And then again, like I said, either MDF or plywood. Now, let me hide this. There's going to be a octagon plate, MDF again, or plywood, whatever. It's going to be secured underneath, and then the octagon itself, the pedestal, I decided we talked about last week, or the last time, I was going to do the 3 legs, and we're not going to do that. We're going to do a decorative octagon. Now this, I didn't do the decorative in the SketchUp drawing, because I'm just not that good with the SketchUp drawing. But when we get over to the Vectric software, you will be able to see the pedestal parts. Let me get maximized here again. Stand by 1 second. On the pedestal parts, the octagon, they're going to be 5.5 inch by 3/4 inch boards. They're going to have 22.5 degree miters on each edge, a total of 8 of them, to create that octagon. But right here in this area on each of the parts coming around, we're going to have this 3D carving is going to be on those pedestal pieces. So we're going to give that pedestal some nice detail. We'll talk about that more in just a minute. And then we're going to also be talking about the foot rail. So this is going to have a base, and I haven't done the trim for the base yet. I left that off purposely because I want to be able to show you how to use the Follow Me tool in SketchUp. If ever you need to kind of trim a piece, I want to show you how to use the Follow Me tool. So I left the trim off so I have something to do. But there's going to be a foot rail. I got to thinking, like when I'm sitting down at the table and all, I like to be able to just prop up a foot or two, right, or whatever. So I think adding a nice kind of footrest or foot rail around is going to look good. And the rail design is similar to kind of almost like this layout, if you will. And we're going to have a 3-inch wide foot rail, roughly around 1 inch thick, 7/8, whatever. And it's going to sit on the rail. Now the rail, again, I didn't get fancy in the SketchUp drawing on the rail here, but what the rail pieces are going to look like, they're going to kind of complement the pedestal. When we come into the pedestal, the rail pieces, let me get this switched around here. Let me turn on both sides for the two-sided view. Bear with me a second. Let me flip over to the other side and make sure the other side is turned on. And let me turn off the zero plane. Bear with me just a second. Let me turn off the modeling plane. There we go. So let me get turned in the proper orientation here. All right, so the back here, let me turn this a little bit. The back and the bottom, that 90-degree corner, that is going to be this area here, okay, that 90-degree corner, and then coming up to the top where the pedestal rail sits, we're going to have this upper area, and it's going to have a little bit extra support here. Now, the rail is going to get glued on. However, I did create enough room that if someone wanted to secure it in with screws, they could drill a pilot hole with a countersink. They could screw from here up into the bottom of the foot rail, and then they could take a plug cutter off a similar type of material, cut a little plug, fill the plug-in, glue, sand, and all that stuff, and kind of hide the screw head and the countersink and all. They can do that right there in that area if they want to, or they could just glue the the footrail on. Either one, but that's going to be this is going to be the supports, the footrail supports going all the way around all the sides. That's going to be the supports there. And that's what I landed on for the design for this table. And yeah, and the JR, yeah, it's screaming for some brass detail, brass parts and things like that for sure. There's all kinds of, there's all kinds of supports where you could do, brass tubing around here. You don't have to get stainless steel in here. You can do, they have different color, brass, gold, all kinds for the cup holders. And then of course you could also do some, some kind of inlay treatment as well too for some, however you want to decorate it up, right? And all that stuff. Let me see here. Yeah, maybe some eyes, crotch cams. Yeah, I got you. Ronnie, so to be honest with you, there's not a lot to this. Really, let's break it down for a minute, okay? And so the base doesn't have to be solid wood. Let's say we were using an oak for this, or even a mahogany. We could use a mahogany or oak or walnut, whatever, plywood base. We're going to be trimming this off, so we would trim it with hardwood. I'll show you how to do the trim in just a second on this. The uprights are going to be solid wood. So they're going to be the most carving. We'll look at the times on those when we get there. The foot rail. Now, the foot rail, if you want to do it on a CNC, for sure you could do it on a CNC. But to be honest with you, a half-inch roundover, half-inch radius roundover on a router table, you would be able to run this board through, flip it over, run it through to do the roundover on the front and the back. And as far as the bottom rabbet and everything, that could be done very quickly and easily on the table saw, but it could also be done on the CNC. So, if it was being carved on the CNC, let's say that this was, let's call it like a kind of a two-sided project. You would have a long board. It would do like a tiling job, kind of almost like a tile job, or you could have individual boards and you can cut out your individual parts, whatever you want to do. And you could do a pocket cut that removes this material. And then you could have your roundover that does, the one edge, everything gets flipped over. And of course, you do the back first, and do that roundover because the back is flat. So you do this roundover first, flip it over, do this pocket, do this roundover, if you wanted to do it on a CNC. And you could do it as one long piece, pass through carving, and then take everything over to a miter saw to cut your 22.5-degree angles. Or you could, on a table saw sledge, you could do, your 22.5-degree angles and things like that, whatever you wanted to do. And so let me back up here. The top parts. So let me pull one of these out real quick so you can see what's what here. So these two parts here, this one and this one, those can be made, you know, on the CNC. Hell, they could also be made. I mean, there's lots of ways they could be made and stuff, but on the CNC, those can be made and very quickly and simply. The little strips that create the box, you have an 1/8 inch strip here and here, 1/8 inch by 1/2 inch, I believe. Yeah, 1/2 inch by 1/8 inch. For your front and back, just to kind of, you know, pin nail or, you know, glue that together. And then you have your 1/8 inch base that goes in between so that when everything is together, you know, and on the bases here, there'd be a small little rabbet that you could cut to, you know, glue this inside base end to the inside of these. And I didn't draw all that in SketchUp and everything, but you know, and you would make 8 of those. So, I mean, there's a few hours for sure in this, in carving time for sure. As far as building and everything, I mean, honestly, waiting for glue, you got your glue up and everything. And by the way, speaking of glue up, the hardware that I settled on, give me a second. The hardware I settled on was this here, a 10-pack for $15. So this furniture, it's called a draw bolt, 5/16, 5/16/18 draw bolt by 3.5 inches long. And it goes into a pocket such as this underneath. So they're going to be glued in, but they're going to be draw bolted together as well on the bottom of those parts. So that's going to be the hardware. And then for the cups, the stainless steel cups, I settled on the 2.67 inner diameter here, the ring outer diameter 3.15 inches, total from the top, very tip top to the bottom, about 2.25 inches deep. And those were those are a 10-pack. You only need 8 of them, but there's no, there's more than 8. Sorry, hold on. What do I got? 1, 2, 3, 4, 5, 6, 7. No, 8. There's 8. So a 10-pack is $21. I believe I said. Did I say that right? 21. Yeah, $21.99. So that was the hardware as far as that, you know, goes. The rest of this, your glue up on your octagon here, and the on these octagon pieces. So if we look at the, we're going to kind of, we're jumping around, but we'll get into this like one piece at a time in just a minute. But let's go back to the pedestal for a second. So on the lower part of the pedestal here, this is the area where the footrest goes. So let me flip this upright. Here. So the footrest, that footrest area is going to be in here. There'll be about a, it's 4 inches up, and I believe this one, I've got it at, let's go vertical from here. Oh, I'm in the 2D view. Hold on a second. So 4.5 inches up is where that area starts. And on the footrest, that back area, you're looking, I got to make it active real quick. Come on. That back area is, you know, 2 inches, 2.1 inch tall there on that back area and everything. So the plenty of room for that. So you're going to need 8 1x6 boards, 3/4 inch thick. 8 1x6 boards, 3/4 inch thick. That would be the pedestal itself. And there's going to be 8 of those carvings, those 3D carvings that we're going to look at deeper in just a moment. But these carvings here. And that carving there is going to take a little while, quite a while, Ronnie, to answer that question and everything. That's going to take a bit. And so I haven't calculated any toolpaths or anything like that yet, so I don't know what the estimated times are. But that's going to take some time. This is a 3/8 inch by 4 1/4 inch wide by 24 inches tall. The overall length of this board is 30 inches. So that's going to be, 30-inch pedestal. And then 5.5 inches wide, a 1x6 board. Each of the pedestal foot rails, those are, kind of a 7x7 inch area. I'm sorry, that's a lie. 7x7, we're going to talk about that in a minute, but 6.5 by 5.5 inch. So a 1 by on that. Now, this is two 1x6s. I keep saying 1x6s, so 5.5 inches wide. But it's 2 of them face glued together to create an 1.5 inch thick board. So this is going to be an 1.5 inch. And then of that 1.5 inch, you're going to have 1.25 inches. This foot piece is going to be 1.25 inches wide and everything. And so let's see here. Glad we all have CNCs. When had a lesson with Kyle about making custom bar rails. Buying that stuff pre-made is of the scale expense, the elbows, $300, $400 range. Yeah, it's crazy. Yeah, mother of pearl, belt buckle cam. Y'all still talking about the crotch cam, so this is also a 1x6, but it's 2. So there's 8 of them. So that's going to be 16 pieces, and they're only 6.5 inches tall. So however many linear feet of that, that is, and all. I'll try to put together an exact cut list, of the boards, but this will be a 2-sided job, and it will be, carved on one side than the other. Now, we're going to get into this in a little bit deeper, and I'm going to talk about how we're going to carve these very easily without having to do like a profile cut and all that stuff. We'll kind of, talk about that in just a minute. Talk about work holding and holding our parts and all that stuff, all that jazz here in just a second. We're going to get into that. That's going to be part of the class tonight. And then, as I said, I landed on the individual parts. I landed on the cup holders, being, on those 22.5 degree angles. And if we look at the other side, the holes for the drawbars, they're going to be there, and everything. And there's going to be a 3/4 inch rabbet from here to this edge. Slight rabbet just for positioning that 2-inch apron. You could butt join it as well too. It's going to be covered with trim. We're going to talk about drawing the trim or carving the trim. The trim will be carved, so that'll take some time as well. But you could butt join it. The trim's going to carve it. I'm going to put a little rabbet on these pieces since I'm carving on both sides anyway, just for positioning when they get nailed together and glued together and all that stuff. Okay, not nailed together, but glued together. And you could actually, on that apron, you on the inside, if you got a Craig pocket hole jig, you can pocket hole that in very quickly and easily. So all together, I mean, this the carving and all, let's say the carving would take a day to do, right? on all the different parts and everything for this. And then, you know, the gluing up your octagon, gluing up your big octagon table, the octagon pedestal. The footrests are going to get secured with screws on the back side and everything. I mean, if you work at it, you could have this done in 2 days, a 2-day build, easily, and get her done. You know, the only tedious part of this whole thing, as far as tedious and all, is the foam and the stapling of the, you know, the contacts, not contact cement, but, you know, the adhesive, spraying the adhesive on the felt and the foam, letting it set up for a little bit to get tacky, and then putting that felt on, stretching it and putting it on without getting out, make sure there's no wrinkles in it, you know, as it goes across, and then of course wrapping and stapling and all. That's the part that takes. That's the part that takes, you know, a lot of tedious little time and stuff like that. Let's see here. No problem on carving times. Just buy a second and third machine. Ask me how I know. All right. So, all right. Let's get into this. So now that we kind of have an overview of what's happening here, right? Let's talk about just really quickly. This bottom base is most likely, I mean, there's gonna be probably leveling feet, inserts and leveling feet put in here. It could be plywood, you know, like oak plywood, whatever your finish is, right? I wouldn't use any cheap plywood and all, because I mean, you know, finish it unless you're going to put a veneer on it or something. But you know, oak, mahogany, walnut, they have all those plywoods and everything. But it's going to be trimmed with solid wood. Now, if you're ever working in SketchUp, I want to talk to you about the Follow Me tool for a moment. And to do that, let me hide all of this stuff. So we have just this area right here. And when you're working with the Follow Me tool, the one thing you have to do is you have to draw a profile, right? You have to have a face. What do you want to follow you, and what perimeter and everything? And so when I'm drawing my faces and everything, I'll usually tend to start with a rectangle, and I'm going to kind of get in the middle of the field here on this kind of straight edge right here. And I'm going to draw a rectangle. If it SketchUp sometimes is tricky. It doesn't matter where. I don't have to be. Oh Lord have mercy! I'm not going to use the rectangle tool because it drives me crazy on this. I'm just going to use my pen tool. So pick a spot. I'm going to draw a line from here straight down. And then, since this trim is not going past or anything, I'm going to come out, and it's going to be, you know, it'll be a 3/4 board probably, and everything. So we will just call this 3/4. Stop messing around now. And so 0.75. And then we're going to come up, and I'm actually going to go up higher. So here is at this face. I'll just draw this face first. So that's here and then across. So that'll finish off that piece. Now, you see how that did that, how that created that, and it drew it crooked? That's because my first line was crooked. Bear with me a second. Not my first line, but my second line. Got to come out straight, not at an angle like this, you know, or anything like that. Come out straight. I need to come out 0.75. And now this is important. I overdrew this line, right? So the Sometimes it wants to act up. All right, there we go. So now we have this face here, okay? Now, with this face, I'm going to still, geez, Lord have mercy. All right, it's still a little crooked. Let me see how crooked it is. I'll tell you how crooked it is. Let me see. It's that crooked. I don't mind it, Lord have mercy. All right, let me cue for rotate. It does not like that edge for some reason. Why doesn't it like my edge? There we go. Okay, that's better. All right, so let me pull that back to a face. When I say push pull, I'm just going to delete this back to a face. Okay, so sorry, ladies and gentlemen. It's been a long day. All right, so now my trim is going to wrap over here and everything. So I'm going to take and I'm going to come in. I think I'm just going to overlap this edge by a ½ inch. 3/8, not a ½ inch, sorry, 3/8. So 0.375. And then I'm going to go over, man, I don't know if my base is crooked. That's why everything is drawing crooked off that. My base might be at a little bit of a tilt, but everything is kind of crazy. All right. I'm going to go over by about let me see here. I'll do a 1/4 inch overlap on this. So we'll come out. And I'm sorry, ladies and gentlemen, this is driving me like nutty right now. My God. .75, comma, 0.75. Holy cow, what's going on with my... Give me a second. My SketchUp is acting weird. Let me just hit save for a minute. Stop messing around. We got a class to teach, ladies and gentlemen. I'm trying to teach y'all, and I can't even get things right. Okay, 0.75, comma, 0.75. You gonna play nice now? Oh, my base for some reason is 1 inch thick. That's one thing that's throwing me off. Okay, so that's fine. 0.75, comma 1. You booger. Let me try that one more time. 1, comma 0.75. There we go. Hell, I don't know. My base is all screwed up. Anyway, enough of that. Wasting too much time on this. All right. Long story short, here's what we're trying to do. We're trying to draw a face. And so I'm trying to get the face laid out so that that kind of somewhat represents the trim. Now, once I get this all figured out how I want it and everything, then I will go in and clean it up. So this is going to have a round over on the trim here. So it's going to basically kind of round over however you want. Not that kind of round over, you goofball. This kind of round over. Why am I struggling today? There we go. So it's going to have a round over. And let me get rid of these lines here. And then on the back side, same thing. It's going to round over. And it's going to... Ooh, that lightning bolt went through the building. Lord have mercy. Okay. The... I'll pull this in just a minute. But, man, that got me. Okay. We still have internet, I believe. I didn't lose internet on that one. So I'm happy with that. Now, on here, let me get this. Come on, dude. Give me just a second, ladies and gentlemen. Holy shoot. Sorry, my mind is on the storm and not on my game here. Okay. Jesus, Laney. Pick the right tool, brother. Now we're cooking with something. Okay, let me get rid of this and this and that. Let me connect that and get rid of that. All right, I'm not going to play around with this too much, but here's the deal, ladies and gentlemen. Sorry. Once we have a closed face, now we have the choice. When we're using the Follow Me tool, it's under Tools, Follow Me, you can click on a face and you can grab that face to extrude. And everything just crashed. Are you joking? Don't send. God almighty, ladies and gentlemen. Hold on a minute. Thank God I saved it. Okay. God help us all. I am just going to I have to do this really quickly. So I want to come out a ½ inch down over. I want to come up. Another 3/8. All right, this is not going to be pretty at all, but it is what it is. Man. All right. So once I have a face, a face that I can extrude, if you will, right? The next thing I need is before I use the follow me tool, because the follow me tool will allow me to extrude this face, along a path, but I really need to kind of select the path that I want it to follow. And so what I want to do here, for me, one of the easiest ways to accomplish this and get this done is to take the line tool and outline the path that you want to follow. So I'm going to hit all of these points here and then come back to that. Now, that area that I just laid out, those lines, I'm going to select them, hold down the shift key, select that perimeter that you just drew. Once the perimeter is selected, then open up the follow me tool and then select the face that you want to follow. And that will create the nice, let me get rid of this inner area here. That will create the nice miter joints and everything for the trim. Let's come in here and hide this. So there is our trim. Let's go on the bottom side of this and everything. And so any trim that you're ever trying to do in SketchUp or anything like that, create the face, draw the lines, and get that single face created. Then instead of trying to select the perimeter of like my existing object, draw the lines around the perimeter, make your perimeter lines, select those lines, and then open up the follow me tool. And once you click on the face, it's going to draw that face around. It's going to follow that path. And that was a long way around, just showing you how to use the follow me tool. But I thought it was just kind of a fun little thing in SketchUp. If you're trying to put some nice trim around the top of a dresser or the bottom of something, or around a desk or table or whatever, it's a very simple, easy procedure if you can draw the face without any issues like I was having, right? So once you have the face drawn and you have your perimeter outlined that you want to follow, and it could be 3 sides. I could be doing the front and the 2 sides of a dresser. Doesn't have to go around the back. It doesn't have to close up or anything like that. Whatever faces you have selected, then it will create that path. So if I were to have selected just this face and this face here, had those selected, and then went into that follow me tool and selected the face, then it would have created the trim, just for those, around those 2 areas, right? So that kind of thing. All right. So what I want is we're going to end up trimming this entire base all the way around. Oops. So let me select those lines again. Go into that follow me tool, select the face, and then create that. And then I can get rid of this surface here in the middle. And then, that'll be that. I'm not going to paint that. That's fine. All right. So let's go in and let's unhide this. And that's the same way. That's the same way this perimeter was created. So if I hide this, that face was created for that perimeter, and the lines were drawn, connecting each of these points. but not just from point A to B. There was also, a diagonal point, and then it went over and then to the center point and around. So the 8-sided octagon lines went around that perimeter as well to create that, to wrap that trim, if you will, or that footstool around so easily and quickly. And all I had to do on that was just draw out the face and then have it follow that path. All right, let's go ahead and let's get beyond that, and let's come up here and let's talk about this trim, because this trim we'd have to make either on the CNC, on a shaper if you have a shaper in your shop, or something, because this trim, let me pull that off. This trim has a nice curve that comes around. On the bottom side here, let me get to a position where I can actually work. On the bottom side, so basically, just so you know, overall on the short end, we are 3/16 on the bottom end here, and then the overhang, we are 1/4, and on the wide edge, so 3/16 is the lower edge, so this ends right here 3/16. And then on the upper edge, this is out of a 3/4 inch piece of wood. So this is overall width right here 3/4, and then it wraps around and down to a 3/16 here. And then there's a, that 1/4 inch, rabbet cut on the bottom. And so on the if we were making this on the CNC, this piece of trim, you can make it as a long stick, have it laid down. It would definitely be a tile job, because then it's going to get cut down into sections, and then we would take it over to a table saw to cut the little rabbet underneath, or a router table. Once that one side is cut, I mean, we could set it in something to do the rabbet on the bottom, but that's all. It's just such a waste of time. It really is. I mean, if you don't have a table saw in your shop, I honestly recommend investing in one, even if it's a little contractor saw or something. But this rounded edge, if we don't have a shaper, then we want to be able to make this trim. We could do this on the CNC, and this is what we're going to create right now. So we're about to create that in Vectric. And so for this, I'm going to add a new sheet. This particular sheet, because I can do multiple of these cuts out of one wide board. I'm already dealing with 1x6s. Just so you know, the overall height of this piece from the top to the bottom is 1 7/16 inches tall. Okay, so let's say that we're going to do this as out of a 5.5 inch or 1x6 board. Let's go a full stick, just for right now. We'll go 8 foot, so 96 inches, 3/4 inch board. You can also, you don't have to do it as tiling. You can do it in small stacks as well too. Cut your boards down in length and then set up, you know, to carve and all that stuff. Let's look at this at a side view. On a side view, this is, let me get a guideline down here. Make a parallel guide 3/16 of an inch. I'm going to go into node editing and I'm just going to drag this node down to here. The line here is going to be a Bezier curve. And we're going to just kind of a gradual curve. We'll get everything to fit within our, you know, make sure everything fits in our 3/4 inch board and all that stuff. This is going to be let's go. Jesus. My mind is like fucking fried or something. I get my height here. I believe it's only 1/4 of an inch tall from this point to that point is 3/8. 3/8. So take a guideline, come here. Going to come down, or to the right, should I say. We're going to create a parallel guide, negative 0.375. Wasn't that insane? It's a positive. I want to go to the right, ladies and gentlemen. Holy crud. All right. And then this is going to be 1/4. All right. Now, on this 1/4 inch overhang, so this is going to literally, it's going to come around and it's going to, at my 3/8 inch line right here, it's going to literally kind of come around and just a gradual curve. So I'm going to go into node editing. I'm going to pull this down to here. And I'm going to turn this into a Bezier curve, and I want to just kind of, it's not really going to be an arc. I'll pull everything back here in just a second. I want to go. Okay. This is going to on this bottom side here, that 3/16, we're just going to have the overhang up here. So literally coming back to here, this 3/16 inch line, let me make sure that is 3/16 right there. 0.1875, 0.1875. There we go. So I need to draw a line here and then here. And in node editing, pull that back, I missed that shot. Okay. Trim that away, turn off these guidelines. Hold on a minute. God almighty, Laney. Get your crap together, brother. Lord have mercy. .1875. My God, ladies and gentlemen, I'll get it here in just a second. It's a very subtle. It's not a very aggressive curve at all. But it also doesn't flatten out. So bear with me just a second. There. Okay. So this is going to be the trim. Now, imagine, if you will, let me join all this together as one. Oh my God. There we go. Join that together. Sorry, ladies and gentlemen. But this, if I rotate it, imagine that profile is getting cut, swept all the way across our board. And we can, at 1 7/16 inches tall, which I believe I still have my height. Let me make sure I got my height right. Lord of mercy. I'm a little off, but close enough. 4375. Okay. So at 1 7/16 inches tall, I can literally run these. I could probably get 4 out of them. Now, when I run these, how I want to run them, if I were going to run them like this, is I'm going to go into the mirror tool and I'm just going to create a mirror copy, and I'm going to flip this to the bottom, create a mirror copy, and let's flip that back up. And then I'm going to take this and I'm going to double it. So hold down the control key. And am I going to have enough room to do it that way? No. So I'm only going to be able to get 3 pieces out of this. That's okay. We can 3 pieces will be fine. So let me go 1, 2. On a 1x5, I'm trying to stick with the same size material, so I don't have a whole bunch of different material that I got to go buy or anything like that. If I want to buy a bunch of 1x6s and all for the majority of the part, let me go ahead and align. Ooh. I'm going to select these 3 items here. I'm going to select this rectangle that I just drew last because I want to align them equal spacing in between and everything. And I also want to align them, you know, just with each other as well. But I'm only going to be using this one profile. But what I need is I need to know where these lay out because I have to draw my lines, my 2-rail sweep lines or my one rail sweep if I'm going to do a molding toolpath. I can do this with Vectric VCarve Desktop, VCarve Pro, or Vectric Aspire. If I'm doing it in Desktop or VCarve Pro, then I need to use the molding toolpath because essentially that's what we're making. If I'm doing this in Aspire, then I can use the 3D modeling tools or the molding toolpath, either one. And when I am doing this, the profile, you got to think about these, in half. There's side one and side two. It's a two-sided job. And so side one, if I were to take this and kind of divide it in half, if you will, I can't do any undercuts. So I have to make sure that this is getting divided in a way that there's no undercuts in the part. And also, I'm probably going to just end up, coming up through, if I can get myself to snap it 90 degrees. And that right there is an undercut. So I'm not going to waste any time with this. I'm just going to I had so much of this done, and I should have thought about the hard stuff in Vectric. I need to reshape this because I don't want any undercut. So I'm just going to pull that up. Okay. I'm happy with that. All right. So I'm going to have a, kind of a side one and a side two of this. So I'm going to go ahead and copy this to the other side. And on here, the only profile that I'm going to be working with, once again, this is the profile, but I'm only going to be working with this half, if you will. That's the part that's going to get cut out of the first side. And so let me get my 3 laid back out again. Once again, I don't know why. I honestly don't know why I'm struggling tonight, ladies and gentlemen. I don't know why I can't articulate or say what I want to say proper. It's like I'm, thumbing through this shit, and I know what to do. I don't know why I'm not being able to say it, so I apologize. All right. Anyhow, we're going to align once again inside that last vector. What this is going to do is going to allow me to get my lines for my, my drive rail, either for my molding toolpath or my 2-rail sweep, whatever it is I plan on doing. So in this case, I'm just going to essentially kind of outline a box, if you will. I'll get rid of the ends in just a moment, but I'm going to snap a copy of that box to there, and a copy of that box to here. And what this will do for me is it will give me my drive rails, if you will. And on the end of these, I'll go ahead and just go into node editing and delete the span on the ends. And then I'm going to take these nodes right here. And if I select this node first and just move it up and get it aligned right here, if I hold the shift key down and select these other nodes, I can hit the letter X on the keyboard to pull them back. Okay. And then the same thing over here. Let me delete the spans. I'm going to select this node and kind of pop it against there, and then hold down the shift key, select those, hit the letter X to pull them into alignment. And that'll give me my drive rails, if you will. So at the top and the bottom of this part that I'm going to be sweeping this profile over. Now, depending on, and this drive rail, I completely missed the end of it. Make sure that's the case for all three of them. It's what happens when you copy a bad vector. There we go. Make sure my tops are good. There's a slight undercut here, overcut. And I'm going to actually fix that. All right, with that corrected, I'm going to copy this. And I'm holding down the control key and the alternate key so it keeps me in line. I don't want to have to go through the alignment process again and everything. I just wanted to kind of get that overcut away. But this is going to be my top half here. And I'll fix the bottom. I'll redraw it or whatever I got to do to make sure everything blends properly on the other side. But on this, we can't, when we're using a profile, we can't have a bottom span. And these straight lines are a bottom span. So we want to get rid of them. And so when you're drawing a profile, you're creating any kind of trim or molding or anything, it's just 3 sides, not 4. So now I can pretty much move these out off the board here. But those are the profiles that I'm going to be sweeping along these rails. Now, when it comes to the molding toolpath, I only need 1 rail for each profile. So whether it be the top rail or the bottom rail, I need to make sure that I am, sweeping properly. And to be honest with you, this profile right here has to be turned 90 degrees like that. When I am, oh Lord have mercy. When you're drawing a profile, it has to be turned 90 degrees so that way it sweeps across proper. So turning it upright like that, it thought the vector was going to go a different way. So if I turn it back, we'll do it with this one down here. If I select this drive rail and I select this profile and everything, it thinks that I'm only running the short side of it, in this area across here. It doesn't realize that I'm running this whole span. But once I turn the profile 90 degrees, then it realizes that, let me draw a kind of a reference here. It realizes that this is the base, that straight line I just drew there, and the shape is getting swept along that base. So the profile has to be turned at 90 degrees. So I'll do the same thing here. And it's just one of the rules of the game. So, and it doesn't matter where they're positioned and all at this point, they're all, laid out. What's important is my rails. So if I'm using the molding toolpath, I want to select the drive rail first and then the profile. Now, because it's 3 different profiles coming across here, it's pretty much 3 separate tool paths. In this method here, it's pretty much 3 separate tool paths getting grouped together so they cut along this board. So one molding tool path, the second molding, and the third molding, and everything. It's not gonna, it's gonna kind of run linear. And so we'll come over here and select the profile first, the rail first, and then the profile we want to sweep. But if I keep continuing on, it's kind of like wondering, it thinks that vector is the second vector that I'm doing on this first piece. If I try to select the 3 vectors and then select the 3 profiles, then I don't select all 3. I select one, and it will know that the 1 is running along those 3 rails. But if I try to select the 3, then it comes in and it thinks that I'm doing something with this. So long story short is, once you have your rails laid out, you can either do one at a time by selecting the rail and the profile, create that toolpath, then do the next one. Or, since we're going across the whole board, select your profile rails. It's going to be funky to begin with. It's going to draw these lines straight down, but keep going. Select those 3 rails, and then select one of the profiles, and it knows that profile is getting swept along those 3 lines. So you don't need those other 2. Okay? So just make sure you select your vectors properly. And it's confusing because you go to select one, you select your next one, you think, oh shoot, right here, once that happens and those lines get drawn, you kind of stop and you go, what's going on, and all that. And you really, if you're new, you can't really figure out what in the hell's happening, what's going on here, excuse my language. But so you don't know to keep going or any of that stuff. You just know that shouldn't be there. And then you don't know that, like if I select one and then, here, and then I go to select the next one and this one, all this funky stuff starts happening. Kind of crazy. But get past the obstacle of selecting your rails, ignoring what pops up. Then the moment you select your profile, it knows that those 3 are the drive rails and your profile is what's getting swept along those rails. Okay? Okay. All right, so with the molding toolpath, we're going to be using, it's just a straight up ball nose, and the a 1/4-inch ball nose is fine because it's just a straight up sweep. There's nothing, more to it. There is material that's getting removed, some waste material here, so you can use a clearance tool to help with that. And then you can calculate this. And if we look along the left side of this, you can see the profile that's getting created. Right? Now these are going to get, we're doing 3 on one board. And the length of that board, I mean, we only need 8 of these pieces, right? So 3, 6, and each piece, just so you know, from long point to long point on this part, long point of the 22.5 degree miter to long point, you're at 22 and a 16th inches. So 22 and a 16th, that is 44 and 1/8. That's going to get you 44 and an 1/8 long board is going to get you 6 of your 8 pieces. Another 22 and a 16th on top of that. So that would be 44, 22, 60, 66 and 3/16. That will get you 9 pieces. You only need 8, so you have 1 as an extra, right? So the length of your board, if you're doing tiling and stuff, only needs to be, you know, the 66 and 3/16. Okay. And so on here, the board that I have set up, I went the full 8 inches, full 8 foot, and you know, I don't necessarily need that. Now, am I going to go straight? Now, listen, am I going to go straight to 66 and 3/16? Absolutely not, because I have to do my 22.5 degree cuts on each one of these, and there's waste. Right? There's waste. You got to have a little bit to burn. So, you know, would we bring it out to, you know, 72 inches, a 6 foot piece? Would we do the full 8 foot piece? Whatever the case may be, just know that there's going to be something to burn. Now, you don't need to waste a whole lot. I mean, on an 8 foot piece, if I'm doing 72, that additional 2 foot of wood, you know, I could cut those down for my, because it's still the same 1x5s or 1x6s, 5.5 inches board. I could cut those down for my foot rails, my little 6.5 by 5.5 blocks. I need 2 of those face glued together to create my parts, right? So out of my 8 foot board, I can get some other wood. I only need what I need, not too much waste. I could sit there, and I'm not going to try to do it right now during class, but figure out what my cuts would be and what my waste would be, and then just have my board only that length. I can kind of plan, you know, ahead, whatever the case may be. In this case, I'm going to make this a 72-inch long board. 66 and an 1/8 is all we need, but I'm just going to go 72. That should give me my waste cuts as well. We'll figure it out in a minute, but it should be fine. And then with that being said, my drive rails here don't need to be that long. And then so I want to recalculate the tool path. And then let's preview this cut and let's see what we got going on. Now, this is side 1, okay? This is a 2-sided job, right? So on this cut, the rough cut, the end mill is going to go through and mill away the waste, you know, however you want to word it and all. And then our finished cut's going to come in and, you know, make this cut. Now, between these cuts, right on this edge, you know, that's where that gets cut and everything. We still got to do the other side and everything, and then you know, cut these parts out. Now, if I'm planning this out, and bear with me a second, I have this rabbet cut underneath that is that it's going to, when my board goes over, I only have a little bit of waste on the outsides. So when my board flips over and everything, there's not a whole lot of, stability and everything. We're going to talk about ways of holding wood in our other foot piece here in just a minute. But on this one, if I were to turn these, let me think about this for a minute. If I were to run these two profiles in this direction and the other profile opposite, facing the other way, I would have a little bit more of a flat, a little bit more of a stability to when I rabbet these pockets off. These two pockets would get rabbeted. This pocket would get rabbeted. I'd have a little bit of wood here for stability to when I flip this over to sit it on. Or I don't worry about that, and I can create a pocket, which we're going to do in a smaller parts. It's not really practical for longer pieces here. It's not really practical for these longer pieces, but I'll still talk about it. But I could create the negative profile of this in a board. So that way when I cut this and I flip it over, I have somewhere for that board to rest so I can cut the bottom side of it. Or I can do just my this front cut here. I can take it over to the table saw and do a rip cut here, 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 and here. And then if I have a joiner, I can run a joiner on there to create that rabbet on the back. I can use a router table and a router bit to create that slot on the back, or I can run these through a table saw with the blade over. If I have a dado stack, I can do a dado cut. If I have a single stack, that's fine. I can do a single stack. I can do one cut and then flip the board over, do another cut, and cut out that L shape. There's a lot of ways to accomplish this, and the fastest way is only cutting this on one side and then doing the other cut on the table saw. Now, by a show of hands of everybody that's watching tonight, how many have a table saw in their shop? Just say I do or I don't, just so I know who has a table saw and who doesn't. Doesn't matter if you do or not. Maybe the CNC is the only thing that you have in your shop, and that's fine. The CNC can be an all-in-one tool, but it's not the only tool, right? And like Ronnie was asking about time-wise, be the run time on this. And if we did the one side and then took it over to the table saw and finished it up, the little rabbets on the back, then that's that. But the with that, it's not just a matter of taking it over to the table saw. Okay. Let me explain to you. So now I'm just talking woodworking here for a second. We have this backside radius as well too. So there's a radius on the backside here. And if I didn't want to do this as a two-sided job, I would make sure that the radius on the backside matched one of my router bits. Let's say that I have a half-inch radius round over. I could chuck that up in a router table, and I can make this cut here, take this over to the table saw, rip my strips, the long strips, take it over to the router table and run this up against my router fence, set just right for my round over, and I could complete this round over cut on the back side here for each strip, full length. And then once that round over is done, now I have that complete curved profile and everything. So I have that complete curve over here. Now I can take it back over to the table saw, and I'm going to do two cuts with this. So the first one is going to be a cut on its back. The blade is going to be low. The blade's going to be low. It's going to be only that overhang is 1/4 of an inch. So the blade's going to be up 1/4 of an inch high. And so the fence is going to be set up against the back edge or the front. It doesn't matter. Pick whichever way you run it through. Okay. But make sure wherever your fence is that you're making that cut here, you know, and you're going to run that 1/4 inch cut the whole strip. So push blocks, you're going to run that whole strip. So now you have a 1/4 inch deep cut running the full length of this stick. Now you're going to turn it up 90 degrees up against the fence at that, from the front side, you're going to turn it up 90 degrees and you're going to come in that 3/8 of an inch, 3/16 of an inch. What's my, hold on a second. It's on side 2 over here. Bear with me just a minute. Uh, 3/16. And so this, mind you, now let me rotate this around real quick just to verbalize this just for a minute. So imagine, if you will, my table saw bed here, and this is going to be a straight line. Oops. At this point, it's going to look like that when it's a full piece. You're going to have your fence, however big your fence is on your table saw. This cut here, this 1/4 inch cut's already been cut. That was the first cut on its back. That first little cut right there, all the way to full length. And then this is going to ride up against your fence and your bed. Your saw blade, let's pretend that this is your saw blade. It's going to be up here. So that's your saw blade and everything. And you're going to run this along. Now, when you run this along, that's going to be removing, that's going to be cutting this waist area here. So that's going to have this thin strip right here between the fence and your saw blade. It's going to be trapped in there. So, use your push sticks. You're going to be standing kind of on the outside because you're going to be running this full 66-inch piece through. And you can, run that cut. Now, that cut is only an inch high. So we're only an inch up. So, as far as scale, this is only 1 inch right here. Now, so as far as, kickback or anything like that, it's not, the blade is going to be buried in that piece, but take it easy, and everything, it'll be fine. You'll have the other end, you'll be able to pull the one strip out and all that. So you don't have to worry about kickback or any of that crap. You'll be fine there. And you'll be good to go. But once you make that cut, since this notch has already been gone, right? So the blade, imagine this is your 1/8 inch blade cut, that first cut right there. Once you run this upright and everything, this little piece is, cut free, and now you've got your notch in the back. So doing it at the table saw is going to be much faster in a router table and everything. And the only thing that you would need to do is make sure that this radius cut here, if you're going to go this full radius, and hell, you can even go straight up and then radius over, whatever you want, but make sure that so on your router table that this profile right here matches whatever bit you own. 1/2 inch radius, make it work. I probably could do, if I did a 1/2 inch radius here with a little bit of a straight lip right there, it would look clean. I don't think, let me look at my actual trim here on the back side. My round over is literally, that is a, based off of a 1/2 inch router bit. So there's no funky shape to it and all. That's a round over, cut on 2 sides here. And then this is the one right here at the end of the round over. This is the one that's got that taper. So this is like a 1/2 inch, round over. So 1 inch, on both sides, basically. Or if I'm saying that right, 1/4 inch round over, 1/2 inch round over, 1/2 inch round over. Yeah. And then this is the part that's molded and all. So it's not this funky shape. I got some kind of weird odd shape here, but if I took this and drew this as a, if I came in here and node editing, I'm going to cut the vector right here. And I'm going to take this vector right here and I'm going to hold it up against this edge and I'm going to hit the letter T on the keyboard. Is it going to let me do it with a curve? Let me turn this into a straight line. Okay. So I'm going to hit the letter T on the keyboard. Okay, maybe the T is not going to work there. Bear with me a second. I'll draw a new line. Maybe it's got to be the line tool has to be open. Hit the letter T. There we go. T for tangent. All right, so it wasn't working on my existing line there. Let me get rid of that span. Go into get rid of this span. Go into my scissors. Cut that. That. And then here, on this straightaway, at this node editing, at this node right here, I don't want it to be a straight line here. I want to delete this point, and I want this to be a Bezier curve, and I'd like to have a nice little bit of a curve coming out, almost kind of like half a heart, right? But now, at that, this part is all getting cut with the CNC right here, and this is just a 1/2 inch, round over bit, to run this part and everything. So the make it fit what you have. You know what I mean? Oop. And so let me get rid of that. And so this would be that trim piece. And on that trim piece, the front half, we are, this part come right down the middle. Let me go into node editing. On here. Oh, don't do that. Lord have mercy. Right here. "90 degrees, everybody." So this is side one. Again, molding toolpath, your 1/4 inch bit. There's no undercuts or anything here. Side one, and then you can take it over to your, once side one is done, once again, once side one is done, you can take it over to the table saw, rip your strips out, okay, right at the end here and here, lay it on its back, run your blade 1/4 inch up, set your fence accordingly so that we're making that notch cut right here. So this part would be on its back like that, and the blade would be here, running that whole strip, that whole length, and then turn the part upright. Again, that piece of wood is still there. It's still square here. Put it up against the fence, raise your blade up to this line here, and rip that little strip out to create that notch. And that's going to be much faster than trying to set up and all this stuff and everything at the trying to do it, you know, as a two-sided thing at the table and all that stuff. All right, so let me fix this because that is the profile that we're going to use. With that round over, there is no undercut at that point. But let me do this really quickly. Let me come here. And let me copy this to the other side. Flip back over to the other side. I'm going to eliminate these profiles actually, and I'm going to take this one, trim that away. Oh, don't trim that line away. I'm going to rotate this 90 degrees this way, and I'm going to go into node editing and delete this span. I'm going to go back into my profile sweep tool. I'm going to select my 3 rails again. 1, 2, 3. Come back and select this profile. And then we're going to calculate. Reset the preview. Preview the visible toolpath. Rough cut's going to cut that. Now, this is on a 72-inch board. At this point in time, you can either set up a miter saw, if you have a miter saw, with a 22.5 degree cut, set up a little fence and stop blocking on. You can make your cuts for your pieces. Your parts have to be 22 1/16 inches in length. And you need 8 of them to create that octagon for your trim, your outer trim. All right, and so that is going to be that versus, you know, trying to do it all on the CNC. Okay, let's move on. To our foot parts for a moment, because this one is a little bit unique, and it is going to be a two-sided job, and we are going to create a bit of a fitted holding piece to it. So there are, on our foot rail, the foot rail, let's go back over to side one here. There's 2 sheets, okay? Now, our normal sheet is going to be 6.5 by 5.5. Again, 6.5 inches by 5.5 inches. And on this, the dimensions, the 6.5 is running along, in this case, the x-axis, 5.5 is along the y. Now, this is going to be 2 blocks, 2 3/4 inch blocks glued together. So you're going to glue up, you need 8 of these, so you need 16 blocks. You don't have to make them the size. You can, make the board a little bit bigger or whatever, but this is right to size, okay? So this is to size. And there is only, there's not a lot of wiggle room and everything on this part. Now, here's the deal. This part, let's look at this in the 3D view here. Let's close this. And let's look at one side. So I'm going to turn off the other side. And I'm going to look at the components that we have here. Now, on these components, basically, if I turn off the flourish here, or the backboard, if you will, this flourish comes straight from the clip art. So on the clip art, this flourish right here is item number 101-15. Okay, 101-15, and I'll see if I can drop a small version of that in there. But that's the entire flourish, right? This part right here. Okay, so that's what the flourish looks like. Now, on this flourish, it's getting nipped right here, you know, where that footstool is going to go. And on the back side, it's getting nipped for this 90-degree area here. Okay, and so coming in here, that 90 degrees is actually like right along here in this part. And then it was sized up accordingly. So this part was rotated, if you will. It was rotated kind of up like this. It was sized. And then it was trimmed. So basically, what I ended up doing was taking a rectangle, kind of figuring out, you know, whereabouts I wanted to come across. Bear with me a second. And in Vectric Aspire, you can delete anything outside of the selected vector on your, you know, your part, right? So if I were to do that, if I were to come in here and select the component, select the vector, and clear everything outside that selected vector, here, then it won't do it while I'm off the board, but then it's going to get rid of everything on the outside of that vector, leaving this part here. Now, opposite of that, if I use Vectric VCarve Desktop or Pro, I can use clipping. So in the level, the component tree level, I can turn on clipping, and anything outside of my vector will get clipped away. Now, with this, there was another model component created. Let me get rid of this and this. And let me turn that off, and let's look at this one. Okay, and this was just a flat model. Now, here's the deal. If you have a spire, you can draw the rectangle and then, again, delete anything outside the vector. So that's exactly what happened here. You know, it, you know, created everything outside the vector, and it created this part right here. And this part, the overall thickness of this part is 3/4 of an inch thick. 3/8 on this side, 3/8 on the other side. So 3/8, so it's just 3/8 on this part. We're looking at one half right now. And if you don't have a spire where you can't create this, you know, flat area, go over to your clip art and go down here, and you have your tabs. So the one that says tabs, bear with me. Up here. I was like, man, I was freaking out. And go down to the tabs, and there is a flat rectangular piece right here. You can bring this in, and you can, let me turn off. Let me do that again. So on this flat piece here, size it up, make it whatever size you need it to be, right? Scale it up to whatever size you need it to be. And that's your flat plane. And then you just use your vectors and you turn on clipping and you clip the part. Okay. So either way, whether you use one of the flat tab, right? And then you clip the part outside, anything outside of the boundary, it clips away. It only keeps what's inside the vector. Or you make it as a model, you draw a rectangle and make it as a model if you have a spire. Either way, point A to B, both get you, it gets you the same position. So let's do it. Let's do it as if we were doing it with a tab, just so you can see. I'm going to go into components really quick and turn off this component. I'm going to scale this square tab up to fit the whole block area here, if you will. And then the vector, so these two here, I can select the vector, hold down the shift key, select the component and all. And if it was the only thing on that component or whatever, I can do clipping. I can apply that to the entire level. And so all you would see is, that part. And of course, the part is get it to the right thickness. So you go and double click on here and bring it down. It's 3/8 inch thick, so 0.375. All right, let me go over to the other side real quick and turn off the other side. And come back in here. And so this part here is off the board. So let me get this turned the right way so I'm not getting confused here. This is this part right here is off the board, and the give me a minute, ladies and gentlemen. That part is not off the board. Turn this off. Turn that on. Ah, that glitch gets me every time. I don't know what it is, Vectric, but fix it. Lord have mercy. I was like, I'm trying to figure out what that line was. Anyhow, had to turn off had to turn it off and turn it back on. All right. So anyway, so there's that part, and that's just using one of those flat wooden tabs. So however you get it done, get it done. But that's the one part. This is the middle. It's 3/8 of an inch thick. All right. Now, once that part is created, now the flourish is getting merged with it. And the flourish also has a 3/8 of an inch base right here. Okay. If we look at the flourish, it has, it's the shape. So the actual shape right here from the top of the shape to the top of the model is 5/16. And then the base, that straight meat, is also 3/8. And the reason for that is because the other part has a little extension up here that goes past this. So when they're both turned on, you'll see when they blend together that this little part is added here. So this part is added, one, to give a little bit more of a foot for that footrest to sit on. When the two halves are, you know, back to back there, we have a little bit more of a foot. And also that area is there because, you know, if I want to drill a hole here and I want to screw up into the foot and then I want to plug that hole, that gives me that wood there as well. So my flourish also has a base height of 3/8 so that those two parts merge together and my flourish sits on top. Okay. And it gives me that part there. So when I go over and turn on the other side, and I'm looking at this as a two-sided job, this top side here has a little bit, you know, besides just the little flourish right there, it has this flat area here, which is a good foundation for the parts to fit on. And the reason why I want that foundation there, there's a reason. One, again, I can drive a screw straight up through there into the bottom of that foot if I want some hardware in there. And I can throw a wood plug there, make sure it follows, make sure the plug grain and the grain of this piece match, go together. And that way it's kind of almost like invisible. But also there's a reason for that. If we go look at the SketchUp design, the foot, this foot area here, and again, this is only 3/4. So imagine this being doubled. That's how wide the foot is. It is kind of in the middle of this run, and the joint, the 22.5-degree joint, is between both of the feet. Now, strong joint, not going to be a problem or anything. You can edge glue it together and no worries there. You can, if you want to, you can use the draw bolt, one draw bolt on each one. You could use a Forstner bit to make your holes and, and a router bit to, cut your path, whatever you got to do. You could do it on the CNC if you want to as well, but you don't have to use the draw bolt hardware here. This is a short enough span. There's going to be plenty of support there, and that glue joint is going to be strong. Nobody's going to be kicking it open anytime soon. But the reason why that flat platform there is just to give me a little bit more stability, at that joint, because it's kind of in the middle of this short run. So I didn't want this piece to be thin. I wanted this piece overall is 1 inch and 7/16, 1 and 7/16 inches wide out of 1.5 inch piece. And so that is the part for that pedestal. For the footrest, Now, on each of those, when you're gluing up your octagon, the pedestal frame, okay, so this area here, this pedestal frame here, each of these are going to get screwed right in the center of that pedestal base. So you will be measuring, marking, aligning, gluing, and screwing each one of these footstools flush with the bottom. So let me hide this. Oh, I didn't make that a group. Anyhow, you take this and this. Give me just a moment, folks. Trying to see if this is grouped in. There we go. Okay. Sorry, I had to figure out how I did my joints, but anyhow, so on each one of these 1x6s, they're going to get 1x6 22-degree cut. Now, there's some waste. These aren't exactly 5.5 inches. They're 5 and the final cut is at 5 1/8, right? So you have waste for your miter cuts and everything. So 5 1/8, long point to long point, 5 1/8. All right, on those 8 pieces, 30 inches long, 5 1/8 inches wide at the long point of that 22.5-degree cut. Okay. The my trim is 7/8. Anyhow, the footrest is going to get screwed, 2 screws, mechanical screws, going right through the panel and into here, and glued. So glued and screwed right there. If you wanted, we can add in, we'd have to change our model up a little bit on the footstool, but we could add in, we could do a rabbit, since we're carving the 3D model on this piece anyway, we could carve a little recess pocket there. We'd have to put that recess on the back side of our footstool and everything so it fits in. But right now I have this just face glued and screwed to there, whatever you want. We can incorporate that in. But you're going to do that first for all 8 of your parts here. And then you're going to glue up your octagon podium, right? Glue up all those pieces and stuff. So run them through your table saw, turn your blade, tilt your blade, and cut that angle on each edge. And you've got, because this part, let's go back to that part. This board is 5.5 inches wide. Bear with me a second. This board is 5.5 inches wide. The 3D carving area is 4 1/4. So this pocket area is 4 1/4 here, right? And so from the center, you got overall long point to long point, 5 1/8 inches, right? So 2.5 and 2.5 is the center of a 5-inch piece, right? So you have 5 1/8. So 2.5 plus a 16th is 2 9/16, 2.5625. So from the center, you're going to measure over 2.5625, 2.5625, and that you're going to make your mark, and that's going to be the long point cut of your 22-degree cut angle on your saw, coming inward this way. Okay. All right. And so The why are you breathing so heavy? Shh, Laney, hush. The what I was saying about the part is if we wanted to put in a slight pocket, let's go let's go 3/8 and 3/8 is 3/4. Let me get rid of that number there. There we go. We could do a pocket cut there, but if we did a pocket cut, very shallow pocket cut, 1/4 inch deep, whatever, just kind of a place for the feet to kind of lock into. If we did that, if we did a little pocket cut and remove that material there, then on the foot part, you are loud. We need to make sure that on this back side here that we have that little alcove. So how we would do that is I can move this whole thing over. I can draw in. I went 2 inches. Hang tight for a second. I can create a flat shape there and make it 3/8 of an inch thick, 0.375. Make it a merge. Take that part, hold on a second, I got to mirror it to the other side. Hang tight just for a moment. Whatever you do to one side, got to do to the other. So I got to delete this. Delete that. Because on this side, those two parts, I moved them over. Remember, I shifted them to the right. So copy those back over to the other side. And now what I have, or what I should see in the 3D view. Wait for it. Let me get this turned around the right way. Work with me. Now, by the way, ladies and gentlemen, the reason why we're not seeing anything on that back side, on the other side and everything, is earlier when I was demonstrating clipping, we still have that clipping turned on. I'm going to remove that clipping. Once I remove that clipping, then we should be able to see our parts accordingly and everything. So let's go over to the other side. Make sure that this is a 1/4 inch, 3/8 wide, a 1/4 inch thick. All right. So now what we have is we have this little 1/4 inch by 3/4 inch. There's one on each side, but we have this little 3/4 inch notch and everything, and that can go right into the pocket that we cut on those uprights, get screwed in and everything. But it gives us more glue, instead of just face gluing this to where possibly the part could be wobbly or something, or it could whatever, I don't know, somebody could be kicking their legs back and forth and you got this thing just all flimsy with whatever, right? So this gives it a little bit more stability, structural stability and everything. So if we do that and everything, and we add that little tenon, that's the word I was looking for. If we add that little tenon on there, on that two-sided cut there, then need to make sure that on the upright, need to make sure that that part is there. So this should be a 2 inch by 3/4 inch. There we go. And the does not need to be a model cut or anything like that. It could be just a simple pocket cut with the toolpath. There's absolutely no need for it whatsoever to there's no need for it to be a 3D model or anything like that, shape or whatever. So we would run that, pocket toolpath, and it'll cut that notch out there on the bottom of that part for our tenon to fit into. Now, the round over, I'm running an 1/8 inch bit. I can account for that if I want to. It's just easier enough for me just to trim off, take a chisel and trim off those corners on that little tenon on each piece. But if I wanted to, I could carve that into or make that into the model on the pedestal. I could take it as far as I want to take it, right? I have the ability. So do you. All right. Let's go back and let me look at some of the conversation and make sure I'm not missing any major questions. John, when you said this, put a dado on each center position in the center and recess the foot rest holds, that's exactly what we were doing, right? That's what you were referring to. Sorry, I didn't see that to acknowledge you earlier. That's exactly what we were talking about for sure. Do y'all hear? I saw someone said they couldn't hear me. The microphone's right at my face. Can y'all not hear me? Testing 1, 2. Testing 1, 2. Make sure y'all can hear me. And JR, yes, it's just me taking a pause between talking because I'm at, my mind is fried for some reason. I have no clue why I can't think straight right now. Let's see here. Okay, y'all are just having a conversation. Let me see. It doesn't look like I missed anything. All right, so good. Y'all can hear me. All right. So on this cut, so let's make one of these panels up really quickly. On this cut, it's very important that we go into, now the machine setup. This is important too for the machine setup, ladies and gentlemen. I want to make this cut really quickly, the 3D rough and 3D finish toolpath, and I want to go back to that footstool because that footstool, pedestal, the holding jig, that's how we're going to end off tonight. The holding jig is what's going to be important and everything. And I want to talk to you about that. And since we just made a change to that footstool, it changes the holding jig up a little bit. So I want to go back to that. But first, let's get this model cut done. Very simple model cut here. We're going to select this vector right here, and we're going to go and do a 3D rough cut. Before I do a 3D rough cut, I want to make sure that my model position in my material is correct. So my material is 3/4 of an inch thick, and my model, let me turn off one of the model components, which is the base here. My model is only 3/8 of an inch deep, about 0.355 or what have you. So on my model thickness and everything, it's not very deep. And then we are going to click OK on this. Hit no. We're going to go do a 3D rough cut. We're going to use our 1/4 inch end mill. We're going to use the selected vector as a boundary and no boundary offset. We're going to do a Z level raster, and we're going to raster 0-degree angle. And we're going to do a profile pass last on that. So we'll calculate that toolpath and get that rough cut done on this part. And this particular board is only going to have the 3 toolpaths: the rough, the finish, and that little pocket cut. So the 3D rough and that little pocket cut are both using a 1/4 inch end mill. They can be done at the same time. And so it really doesn't matter at that point what bit you're using. Time for dinner, Laney. Yeah. It's starving to death. So we have that 3D rough. And then the 3D finish. Now the 3D finish, there's a lot of little detail in here and stuff and everything. And so, but a majority of it's big. So I'm going to use my my go-to bit is going to be my 1/8 inch bit, but I'm also going to be using my 1/16 inch to do some kind of touch-up areas and stuff and everything. And so on the 3D finish cut, I'm going to have my 1/8 inch tapered ball nose, and then I'm also going to have my 1/16 inch tapered ball nose. And the again, using the selected vector as the boundary, and again, doing a raster cut 0-degree angle on those with a no boundary offset. No boundary offset on that. And so that's it for this board. Once this is carved, once this is carved 8 times, we need 8 of these. Take them over to the table saw, tilt your blade, make your cuts, and adjust your fence. Do all. Make sure you make that mark, that 2 9/16 from the center, right? Make your mark. Get your fence lined up for that first long cut, right? Cut all of your pieces. Don't cut, and then you could cut and turn around and cut and everything, but in that your long point will ride up against the fence, for the second cut, because it's going to be the same distance and everything from on there. But the run all of your one side and then come back and run all of the other, or run one side, flip it, do the other. But it's just faster if you do get all the one cuts done. Bring your stack back around, set up, run the second cuts, right? And that's going to complete these. That's going to have these ready for waiting for glue up and all that stuff. Your footstool's going to go in. Your foot part's going to go in first. Screw from behind. 2 screws. If you want to, you can pre-drill your holes or whatever, and countersink on the inside. It's never going to be seen, but that's up to you. Whatever you want. All right, so let's preview that cut. And so all the way around this pedestal, you're going to have this 3D cut all the way around. So it'll give it a nice high-end look. And again, now this model that you see right here is from the clip art. It's from the decorative clip art, and it's the 101. Hold on a minute. Let me find it. One 101-18-X. 101 flourish. 101-18-X. That's this entire thing right here. It was dropped in, sized up. My opening, the rectangle, is 4 1/4 inches by 24 inches. Okay. By 24 inches. So this is what that part's going to look like when it's done carved. And now let's go in a little tighter here. Look at this. Look at all this area right here, right? So what bit do I need to go in there to clean that up? Because that needs a little loving. So bear with me a second. Let me make sure that my model resolution is still set proper. First of all, it is. Let me make sure that my 1/16 of an inch bit got run in this. It did. Let me go back into my toolpath. And okay. This is kind of, no offense to design and make, but y'all step up your game, guys. So the model, I'm at my highest resolution, 50. And the model is very rough around the edges. And that roughness is translating. Even at the highest resolution, that roughness is translating here. You know, so I am going to be using on my small tapered ball nosed bit. It's a 5.2 degree or 5.4 degree side angle. So what I'm going to do here, and unfortunately, adding a draft is only an Aspire feature. Yeah, you know, gold leaf would look good, right? But I'm going to end up adding a draft to this at a 5.4 degree angle. In that draft, that's only an Aspire feature. So unfortunately, if I were, if I tried to come in here with a finer bit, let me just show you what happens if I try to use a finer bit. So I'll come in here and we'll use a 1/32 bit with a 64th radius. The roughness of the model and I'm not crapping on, you know, design and make, but if I'm spending $25 on a model, I know this is part of the free clip art, but if I go to design and make and I buy a model for $25, I better be getting the highest resolution possible. Right? I love Vectric, don't get me wrong. And I love design and make. I love Todd. I love everybody over there. Becky and all them. They're all amazing. But I don't want to have to jump through hoops. If I had Vectric VCarve Desktop or Pro, and then, you know, I'm going to show you what it's going to look like when I'm doing this smaller bit. Smaller bit's not going to change the outcome of how bad that model looks at the bottom of its base and everything, right? Now I could try to apply some smoothing, try to apply enough smoothing that it cleans up the edges some, but doesn't lose any of my detail on the top side. And from there, but adding a draft is only an Aspire feature. I would not, Brooks, I would not do sculpting on this at all. I would not waste any kind of time doing sculpting on this. I would do an overall just, you know, a blanket smoothing to see if that fixes anything. But the coming back in here with the smaller bit and everything, as that progresses through, it does help. So you can see we'll get up here where the still a few, but it does help. The smaller bit does clean that up. Now that added an additional 7 hours. That one bit added an additional 7 hours to the cut. Ooh, logy. Let me see if I can. My God. Let me see if I can clean some of that up without having to run that smaller bit. I do not want that 7 hours. So let's play with this for 2 seconds and then we'll move on. So let's come over here to our components. And on this flourish, I can just try to apply a smoothing. So let's turn off all the models on this side. Go to our 3D view. Close the preview so we're just looking at the model. And you can see that rough edge there. We can try smoothing that. Now the component wants to be baked. And that's fine on this one. I don't mind baking this one because this one is made up of all of the, let me show you all these components. So that one component, when you drag and drop it, there's 18 parts in there, basically, that make up that one entire model, right? And so what the software is saying is, before I can smooth it, those parts need to be baked together. And I'm okay with that on this one. Normally, I don't bake my parts. I keep my originals intact, and I'll make a copy of it and all that. But on this one, I don't mind baking them, that component together as one. Now, when I do that, again, I can go over here and try to smooth this. But if I smooth this, let's preserve the transparency. That was at maximum smoothing, what you just saw there. If I come in here and do a little bit of smoothing, because I'm trying to smooth the edges, not lose the detail on my top, right? So one without the other kind of thing. So let me bring this up a little bit. And as we look at those cuts, so now I'm halfway, and as I smooth this over, I'm just going to go the full way for a minute. As I smooth this over, I'm smoothing out my detail up here and everything, and I don't want that rounding over and smoothing on there. When I'm here, I want those edges and stuff. So smoothing is not going to get me where I need to go on that, to an extent. The only other option I have is to add a draft. Now on the draft, I'm going to match my router bit angle, in this case, 5.4 degrees. And I'm going to hope that on the draft, that doesn't do anything for me either. Let's step that up. 5.4, let's go 11 degrees. Area here. Still, I mean, all that does, it kind of blows it out, but it's still really rough around the edges. God help me. Let's see here. The only thing I could do at that point is I could probably do a combination. I don't want to go, I'm going to go crazy with the draft for a minute. I just want to see something here. I'm going at a crazy angle that I would never go at, but I just want to see how extreme my angle is, what that does for me here. I want to see if that changes anything. Time for a poker channel stream angle. You see what that does there. So that, blows everything out, but it takes care of that, it blows everything out, but it takes care of that edge, cleaning it up and everything. So let's do it this way. We won't go. Let's go. Let's back it up to 22.5 degrees. So 11 doesn't give me a whole lot. 22 or 32 gave me more than I wanted. I'll live with that. My extremely high. Okay, so I'm going to live with that on my edges. So I'm going to go back into my components here. I'm going to turn off this original model. I'm going to go back into this, and I'm going to, on this model with the draft, all right, that's about as far as I'm going to take that. All right, so with that being done, I'm going to go back into my components, and I'm going to open my other area back up. Let's go in. I'm going to get rid of that bit, recalculate. Well, first of all, let me turn off this component. Slide that back up to the top. Click OK. No, and I'm going to open this back up and remove that smaller bit. Go back in and calculate that again. Yes, it does take a hit, but we're finished. We should be moving along right now, and then we're gonna be wrapping up here in just a second. I want to talk about this foot pedestal. It's very important, and then we'll move on. All right, so it's wrapping up here. All right, so now if I go back in there really quickly and reset that preview and preview all the toolpaths again. Sorry about that. We should be good to go. All right, yes, so that is resource hungry. Man, my hands are tore up. So the stream probably froze for a moment while it was calculating that. That bougainvillea, ladies and gentlemen. Couldn't find my work gloves, I saved my life, and that thing has tore me up, man. It's got these spikes, and they're harmful to humans. Well, they're really harmful to my dog. My dog, it cost me. She got one in her belly. Had to take her to the emergency vet. It stabbed her right in the stomach, and it swelled her stomach up, and cost me a little over $1,000. Yes, you did. So cutting that bush out, getting it out of the yard and everything. Well, the thing keeps coming back, man. The roots are. I thought I dug up all the roots. Well, this heavy rain that we've been having, it's come back, and these spikes are, man. Went to cut them down, and didn't have no gloves on. They just grab you, dude. They stab you and grab you, and I haven't had any like negative effects from the poison from them, but my hands. I got freaking stick marks and cuts everywhere on them. All right. Thank God I don't have any. Look at that crap. All right. I'm going to get rid of the 16th inch. That's a lie. I'm going to get rid of the 1/8 inch. And I'm just gonna. I gotta bring that tool in anyway. The 16th inch taper ball nose just can't get into it. It just can't get into it to. Excuse me, ladies and gentlemen. It can't get into it to get the detail that I want. All right, so let's see what that does for me really quickly. We'll see what that does. Okay, somebody's bit is not set up properly. Give me a second here. That's running a little slow, but that might have been another reason my 16th wasn't running very good. So hold on a second. Now I got to go back and make sure that wasn't, for some reason, my 16th inch bit was stepping over 40%. Never have a finished bit step over 40%, 8% or less. So now I got to stand by a minute. Now I got to calculate this toolpath with just the bit with the proper step over. I want to make sure that that wasn't my problem the whole time. I mean, of course, the model detail was the problem, is a problem. But at the same time, I want to make sure that that thing being set, I don't know how it got set to 40%, but I want to make sure that that's let me just see. I'll know right away. No, it's still. All right. So it's still a little bit too big to get into the detail area. So my final toolpath will include give me a minute. Don't make sure we don't freeze up. Okay, that's it. Spent too much time on that one. Yeah, I know I'm breaking up. Stand by, John. I'm not really breaking up, John. I'm actually not talking. I'm pausing. Rather than sitting there and going, I'm just not talking. So I'm literally in the middle of like my thought or my sentence and all. I'm just stopped talking, and I might cut myself off in the middle of a word or a sentence. No, it's irritating, but y'all do me a favor and please handle it, because my mind is, I don't know where my mind is right now, but it's like a space cadet. And I don't drink. I don't know what's going on. I don't do nothing weird. Lord have mercy. All right, so now to move, let that finish. It's almost done. All right. So now that smaller bit's going to go in and touch up these areas that you see here, these tool marks. And so it will go in and kind of clean those up to the best of its ability and improve that. It's going to increase the cut. It is what it is. But so now I'm looking at 7, 8, 9, 10. 10 hours. I don't know. I'd have to go in there and look at it a little bit more, but 10 hours panel. That's crazy. Anyhow, it's worth it. Okay. Let's go to my sheets and let's go back to that foot rail. Now on that foot rail, ladies and gentlemen, we talked about this a moment ago. We added to that foot rail, we added this little kind of dado in the back end. Tenon, not dado. We added this little tenon on the back end. And so I need to account for that on my this part over here. So on my sheet 2, which we're going to talk about in just a second, I'm going to go ahead and make it active. And I'm going to delete that. Sheet 2. This is the last part. We're wrapping it up here, but this is important. This one's important above all, how we're going to machine this and how we're going to hold, work holding and all that stuff. So we're going to delete this, delete that, get rid of that. We're going to come back over here and we're going to select everything except for that measurement. We're going to copy that to the sheet 2. Now, sheet 2 is going to be a larger piece of material, 3/4 inch MDF. MDF 3/4 inch is what I would recommend. The part itself and everything is going to be a mirror of what we're actually, our side 1 here. So sheet 2 is the model and everything. It's going to be a mirror. So I'm going to flip that. Horizontal. And I'm going to center it on the board. First of all, let me get rid of this vector there. Center that on the board. And then I'm going to come to my little, this new vector that I created right here. And I'm going to trim these two together. I need just one boundary on this particular one. So I'm going to go into my scissors and trim those two together to make that one outer boundary all the way around. Okay. Now, this is important. So in here, I want to make sure that on side 2 on this sheet, I want to make sure that there's no model on side 2. So I'm going to flip over to side 2. Make sure there's no model over there, just one side. That's all I need in this instance. Okay. And this model, which is a mirror to the one that I'm actually going to be, the one side I'm cutting, this is going to be subtracted. So in my job setup here, my material setup, from the top of the board, I am going to, it's important that I'm at the top of my material and that the component is reversed. So these 3 parts belong up here, and the 0 plane can be there. But in the 3D view, let me get out of this hold here. There we go. All right, let me get over here. Okay. Now, this is too deep right now. This is not the correct settings for this. One of my components is set incorrectly. So give me just a second to figure out which one it is. My model should be, one side should be 0.6875. Okay. Go back over to side 1 and verify that. I need to turn back on for a minute. I need to turn back on my view of the modeling plane. There we go. All right, so right now, let me switch over to side 2 for a minute and turn all these off. right now my model with this back component and all of these, we should have a model height of 0.6875. Okay, good. Now, look at this very carefully in the job setup. So, remember, I'm going to have two 3/4 inch boards glued together, okay, for 1.5 inches. Now, the model itself here is 1/2 is 0.6875. So that leaves 1/8 inch of material. The other model, the other side, 0.6875. That leaves 1/8 inch material. Okay? And the hold on a minute. Hold on a minute. My math is not mathing. 0.6875 times 2, 1.375. That leaves a 1/16 of an inch for each side, ladies and gentlemen, not 1/8 of an inch for each side. So this 1/8 of an inch of material right here, this gap above model, when I'm carving the actual model, ladies and gentlemen, the model, it's important that this gap above the model be the 1/16 of an inch. And because there's going to be, there's two sides to this thing. So when one side carves and the other side carves, the 1/16 of an inch is going to get milled away from both sides. And then together, I'm going to have that 1 3/8 inch part, you know, the finished piece. Out of that 1.5 inch piece of material, my finished piece is going to be 1 3/8. So that leaves 1/8 inch of material, and that material gets milled away 1/16 of an inch on side 1, 1/16 of an inch on side 2. And it's important that we go into our material setup and we make sure, if you're doing something like this, it's important to make sure that that's exactly what happens and everything, because we need that to be milled away. Now, that is my material setup for this piece. Not for my panels that make up my pedestal, not for the parts that, that make up the pedestal, not for any other 3D model parts or anything like that. It's just for this piece, so this job setup. So with this setup here, when I click OK, this is where, once this setup is done, on this sheet, you go in and you create your rough cut, your finish cut, tool paths, and things like that. So for me, you know, it would be selecting the vector. And in this case, we have a new vector, new layout, right? So we come in here, and these two parts have to be trimmed together because we added that tenon on after the fact. So trim those two together. Now, this tenon here is, 3/4 inch wide, but it should only be 1/4 inch long here. This looks a little heavier than 1/4 inch. So I'm going to measure this real quick. And it's 1/4. Okay, good. All right, so it looked a little heavier, so optical delusion. All right, so this vector here, selected vector is the boundary. Model set up, with the proper 1/16 of an inch above the part, because it's going to get milled away. All this brown wood here is side 2, ladies and gentlemen, right? Side 2. Now, when I create the tool path, we're actually going to be milling this wood away, not just in here. We're going to be milling away this front half of this board. Very important to understand this. So the all of this is going to get milled away. Now, what I'm going to do right now is I'm going to select this vector, and I'm going to center this, shift it just a little bit so I'm kind of centered there on the material. And the 3D rough cut, 1/4 inch end mill, selected vector is the boundary, is not what I want in this case. It's material as the boundary. Now, let's assume for a moment that you have clamps or screws or something or whatever over here. All this wood material right here is going to get milled away. All of this. Okay, halfway through the board. Understand that. Halfway through the board. So it's getting milled down. So all this waste wood is getting milled with it. And in the case of this, if I use the material as the boundary, my bit is going to stop right at the edge of the material and leave this funky little lip and everything going on. And so what I want to do is I'm going to actually draw a rectangle around this perimeter. I'm going to offset the rectangle, I mean, just ever so slightly. It doesn't have to be a whole lot, but just past the edge. So the bit kind of breaks that edge slightly. And since this whole surface is getting carved, you got to think about how you're going to be screwing or, setting this down, securing this down. Now, there's keep out zones that you could use. You could have a small little screw area here and here or whatever that you can screw down for the top. You can draw a little vector, and in your software, your Vectric software, you have what's called manage keep out zones. If you have never used keep out zones before, let's pretend that I have a screw here and a screw here screwing down into my wasteboard or a scrap piece of wood or whatever, and I don't want my router bit hitting those areas, right? Those areas that I want it to kind of stay away from them. I could draw a vector. It doesn't have to be a square, it doesn't have to be a circle, it doesn't have to be anything, but I can just draw a vector, make it whatever size I want around kind of where that screw is going to be. And in my keep out zones, I can say, okay, from those selected vectors, let's say we say stay 1/8 of an inch away from those selected vectors, and then we can create that keep out zone, right? So any toolpath that gets created is going to go around these two areas. So if I come over here and if I have those turned on and I come over here and create my 3D rough cut, 1/4 inch end mill, material is the boundary, no. Selected vector is the boundary, and I want that rectangle selected. And I want to go calculate. It's going to hold on a second. Okay. It is going to violate that. So I can't just have that circle. So I need to come off the board. So I do, in my case, have to draw a little rectangle. I'm going to draw a little rectangle around just like this. As a matter of fact, I'll just make it simple on myself. I'll just draw a rectangle like that. I'll do another one here. I will use those. Let's go back and manage our keep out zones and clear that. Come back and select these two rectangles. Come on, dude. create that, and then let's go back in and recalculate that. Now what are you violating? Let's see, the toolpath could not be created without violating the keep out zones. Moves where the toolpath violates the keep out zones and mark. So it's saying that it's violating the keep out zones. That's so stupid. The whole purpose of the keep out zone is not to violate the keep out zone. All right, so that's all right. I'll fix it. Node editing. Insert a point. Don't know why I have to do this, but that's okay. All right, I'm going to select this vector here, select this one and hit the letter X. And I'm going to select this vector here, select this one and hit the letter Y just to straighten that up. That one's okay. Let's take this, bring that down just a little bit. All right. That's fine. 3D rough cut. Calculate the toolpath. You're done. Got to get past this part because I tell you. Yeah, I'm sure it's going to be quite a bit for these corbels as well too. All right. I'm okay with that, whatever it's telling me here. So when we preview this cut, okay, so the it's just going into my little offset area, the little 1/8 inch offset area, which is no big deal. I'll fix that in just a second. But this is important. 3D finish cut. On the 3D finish cut, I'm not even going to waste time with it. I'm just going to go straight to the no 1/8 inch bit, just the 16th and the 32nd. Not going to do an 1/8 inch bit. It's just too big for these small parts to even really do any good. At least using the 16th, they'll get a majority of the material away to reduce the run time, so the smaller bit doesn't have to do a lot of work. What's important here is when this is all said and done, like I said, I don't know how you're screwing it down, but we only have to deal with the hold downs for one side. We don't have to deal with it when we flip it over. So here in this scenario, we got 2 screws that going in, and we have the toolpath going around those screws, right? And so what that means for us is that we have these 2 posts kind of sticking up that need to be gone when this is said and done. So we're going to have to take like a little flush trim handsaw or something, a friggin' chisel. I don't care how you get it, but you're going to have to knock those little pedestals off. I'll show you what I mean in just a second. when it finishes calculating. And then, yeah, Brooke, I would change. I'll go through and optimize all the toolpaths and stuff, but I'm not going to try to do it at 11 o'clock at night and try to explain all this at the same time. The finished project will have all the optimized toolpaths and the redrawing of the vector so it doesn't go into the screw areas and all. But this scenario is important to just kind of understand, so you can understand what this other sheet 2 is for. Okay. Now, wait for it. It's almost done. Now, ladies and gentlemen, this might be a little bit all over the place and everything, but I want you to understand something while this is calculating. This is a project that it's a good it's a nice project. Like if you ever wanted to make something for, you know, a man cave, woman cave, you know, she shed, whatever you call them nowadays, but you know, game room, whatever. It's a nice table. And so with that being said, it's kind of one of the more involved projects that, you know, that I'll ever, you know, teach here besides signs and stuff like that. So on this one, I'm actually going to take some time and put together a set of prints. The plans, not prints, plans, that have instructions, cut list, material list and cut list, dimensions of the parts, all the parts broken down, the build, the carving, all that. So I'm going to write this one up. And it is what it is. Now, I can tell you right now on the optimized toolpath, I'm not going to do it right this second, but on the optimized toolpath, this area here and this area here, I will use a pocket toolpath, so it'll be much faster. It'll pocket down, and my 3D cut will only focus on the 3D area to minimize run time right now. Right now, my bits, my little 1/8 inch and 16th inch bit are trying to do all this flat area here when it absolutely does not need to. Okay, it's just a waste of time. So a 1/4 inch bit and everything will come in, and the 1/8 inch or whatever will come in and cut this out and flatten this up, and then the finished bit. But for preview purposes only, I'm going to go ahead and just run this, all this jazz and everything. And then we're going to talk about these 2 little posts that are sticking up, and we're going to talk about what we're going to do with this part. Okay. So let this preview finish. Hang with me for 10. It should only take 10 more minutes, 5 more minutes, 10 more minutes, just to explain this. All right, now let me turn off these keep away zones for a minute. All right. On here, our part is going to be carved out like this, our half of our board. The bed here, okay, this depth right here is 3/4 of an inch. It is our 0.6875 plus that 1/16 of an inch that got burned right out of the get-go. This flat plane is 3/4. Okay, right here. Now, because of where the screws were or whatever, because if you use two-sided tape, hey, that was great. You didn't have to do any screws. You don't have to screw around with it, none of that stuff. But these two little pillars, let's say that's where we had screws screwing this part down. Now, here, that post on both corners needs to be cut off. It's got to be cut off, flattened up. I don't care if you use a chisel, you use a handsaw, you do a table saw, I don't care how you do it. They got to be gone. They need to be flat. So, hell, you could take the whole corner off if you want to. I don't care, right? You could just literally nip that corner right off at a diagonal, boom. Nip that corner off at a diagonal, boom. I don't care. Just they got to be gone. Okay, it's important that this area here is flat, and this is 3/4 of an inch thick. Now, we are going to then flip this board, and this board, which I've got to change, I got to fix my size here in just a minute, but anyway, go back here. And that part, this is my other part. This negative cut is going to get cut into, and I said 3/4 inch MDF. You're going to need to go a little thicker. So 2 pieces of MDF that are 7 inches by 7 inches is fine. Face glue, 2 pieces of 3/4 inch MDF. This part is going to get cut out in a negative. So the part's going to be a negative cut here. Okay. So you're going to run your toolpath and your MDF to create this negative piece. And this negative piece is it's the model, instead of up, it's in, carved in. Now when that model gets cut on that part's going to get flipped over and it's going to get pressed down into here. And this is what's going to hold your piece of wood. So this will be clamped on the table. Your piece of wood is going to be clamped, pressed down. That part's going to be pressed down in there. It's going to be clamped down. And you're going to run the side 2 model cut. And it's going to cut down to this plane right here. It's going to cut down to this surface. And when it cuts down to that surface, this part, when it comes out, is going to be a finished part. You won't have to do any profile cutting. You're not going to have to do any, you might have to do a little bit of, right on the seam, you might have to do a little bit of trimming and all that stuff. Not trimming, but sanding and everything, but very little. Your 3D finish cut is going to carve just like it did on the other board you just saw, but it's going to carve, and it's going to carve the second half. And so this little 7x7 jig is what it is. It's a jig. That's what's going to hold your part. So when you cut all these corbels, you cut your side 1s, you're going to flip them over and press them into this jig, and you're going to run side 2. No clamps needed, no screwing down, none of that stuff. It should stay just right where it's at while you carve that. You shouldn't need any vacuum suction, no hold down, no clamps, no this, no two-sided tape, no blah, blah, blah. None of it. If you want to use two-sided tape or something like that, that's up to you, but you don't have to. It's not required. So anyway, that part's going to fit in there. and you're going to run your side 2, and it's going to mill down to the surface of this. And when it does, that's going to clean up the other half of this cut, basically. And you're going to end up with your corbel. And you're going to rinse and repeat those 2 cuts. Well, 4 cuts, your rough cut and your finished cut, right? For both sides. And but this is going to be your jig. And again, take some of your MDF that you have hanging around the shop, cut yourself down. And it could be plywood, it could be anything, but just something that holds its edge. MDF is going to be really nice for you. Foam is too soft. It's not going to give you a good hold. MDF or HDF, if you have any HDF in the shop, but MDF is probably what most common and everything. And it's got to be, because our model's 3/4 of an inch. 1/2 of it is 3/4, the other half is 3/4, right? And the model's not, just so you understand, it's not 3/4, but that's how much material gets milled away, right? Because a 1/16 of an inch gets burned on the outside edges, and then we have 1 inch and 3/8 in between. But you're gonna mill that down, and you're going to plop that down, and your second cut's going to cut to this. So you're going to have a tool path and instructions and all on making this negative part holder, if you will. And this is going to be a cut that's going to be well worth the time. Your part's going to fit in there almost like an inlay. It'll fit nicely, don't worry. And then no, I would never attempt to do a corbel on a rotary. Absolutely not. I mean, if I did, it would be just the same as cutting on the table, but it would be 1 cut this way, flip it 90 degrees, 1 cut that way, 1 cut that way, flip it again. And so I can do that on, on the table. There's no, no, to answer your question, no, JR, I would never use a rotary on that. It's a 2-sided part all day long. Anyhow. So now you want to learn how to do it on a rotary or something like that, or learn how to do a cut like that or something, JR. I'll give them a little bit of a shout out. I don't like them at all, but Legacy. Legacy has a class, Legacy Woodworking, Legacy CNC. They have a class on corbel, cutting a corbel and doing it in multiple sides like that and everything. And I think they do it on the rotary. So if you ever want to check out that, Legacy CNC, go to their tutorials. They're not on YouTube. They're on their website. But anyhow, so this part is going to be a part that gets cut. And yeah, there's time involved in it, but I only have to carve this part once, this part here. And anytime I make this table, because hell, this may be a table that I make and sell to make and sell. I have a jig now that will hold my corbel parts while I'm cutting my side too, right? So it'll get when it's done, it'll get put away and used again. I would probably, if I were going to use it for more than one, I would probably spray shellac this very lightly to seal it so the MDF doesn't absorb any moisture, like if it's stored in my shop or something like that with the humidity and all that stuff. So there's no swelling or anything like that. I'd probably spray it lightly with shellac, Zinsser shellac, to seal it. But I can also now test fit this and everything to make sure I got a good, nice friction fit and all that. I got to have one half of my corbels made and all to do the test fit and everything. But I don't know if any of you have ever signed up or thought about signing up or whatever for the CNC woodworker, like the CNC boat builder company that does the CNC woodworker class. They have one of their class sessions and all have this type of holding method. It's really good. And then Edwin says, is there anything to be aware of when positioning the negative on the CNC table in regard to XYZ zero position? No. The only thing that you want to, I mean, because it's all the cut's going to be based off of, the bottom left corner or anything like that. So on your tool path, like on this tool path, the side that gets cut, it's based off of the bottom left corner of a 6.5 by 5.5 part, right? So on this part here on the negative, the board itself is 7.5 by 7.5. So you may want to have the male you either want to have the part that's getting cut out of the same size material or what have you, or you need to make sure that you're starting from your offset of that 1 inch difference. No, JR, I don't have a link handy. They're all over Facebook, man. They're all over. Their ads are like all over Facebook. Let me see here. Here's an ad. Bear with me. It is danleeboatbuilding.co.uk, and this was off the ad, so they're running a special right now, 98 euros. Normal price is normally 275 euros, so there's a discount. But they have a lot of techniques. So I'll show you one of the Facebook ads. And I'm advertising for you, Dan Lee, so don't be flagging my freaking video. But CNC woodworker, they teach work holding, vacuum holding. They teach about, odd shape, parts, working in Fusion, working in Vectric, vacuum, router bits and information about router bits, jig setup, CNC, step overs. I mean, they cover this course is, they cover a lot, right? Dan Lee, if you flag my video, I'm pissed. Anyhow, so on Facebook, their ads play every freaking, I mean, they're all over my Facebook feed, but danleeboatbuilding.co.uk, and on their Facebook ads right now, they have like 70% off, and so it's 98 euros instead of 245 for the course, but you have lifetime access to it. The courses are really in depth, and that. Anyhow, how would cutting 4 corables in one piece affect the carve time? So it's still got the carve time is going to be the same times 4, Brooks. I mean, it's still got to carve the 1, 2, 3, 4. So the amount of time that it takes to carve the 1, it takes to carve the other, the 3rd, and the 4th, right? So it's just the 4 times. It's always going to be 4 times the cut length of 1. So if that answers your question. So that's that. So anyhow, you're going to have a part, and in the instructions, I'll make sure that who asked that? Edwin Fisher asked that question. In the PDF and in the instructions and everything, I'll make sure that start points, X, Y, 0, all that is mentioned, in the setup and all. I'll make sure that is all mentioned so that it covers all those bases. Now, as far as, a 5 or 6 short tutorials of key techniques and everything, I'm actually probably going to do that. This is probably going to be an actual build video. So where I'm actually building it, like all the woodworking part of it. I need to, it's been a long time since I've done a woodworking tutorial, woodworking video and everything. And I need to kind of get back into that. And this project is one of the bigger projects that I've ever taught. So this one, there's a lot of steps involved. So this one is, the PDF is going to help, the prints, and, the cut list and all that stuff. But there's probably going to be a visual video with it. If any of you if you've never seen, give me 1 second. All right. So if you've never seen, like on my other YouTube channel, my octagon picnic table build, right? Building an octagon picnic table, part 1, part 2, part 3, part 4, those videos and everything. With those videos, it's a step-by-step, on all the parts, all the woodworking and the assembly and everything, the build, the whatever that is, right? And along with that is a PDF, or is a PDF that has the material list and cut list, plans and dimensions, instructions, right? So a full set of step-by-step build plans, right? And the same would go for the octagon poker table, right? So yeah, if any of you are looking to build an octagon picnic table, these plans are for sale. They are $10 a download, but they are for sale. Laney.Shaughnessy@spindletv.com. You can email for them because my website's down right now while I'm working on putting up the redesign. Anyhow, so yeah, there you go. Facebook, right? That's why you've never seen them. The long story short is this negative of our part, and this could be any 3D model where you have to carve on the back. You could carve a negative of any 3D model, and you flip it over, and now you have something that really stably holds your part. There's no worries about, I got to leave this extra wood so it supports itself, or this or that, or what happens when I cut out and I got to leave tabs in the middle so the pieces don't fly, and this and that. None of that crap you have to deal with this. You carve your first half, flip it over, press it down into the mold, carve your second half, pull out a finished piece. That's it. No profile cuts. No nothing. It's all 3D rough, 3D finish. Done. And that's it, ladies and gentlemen. So we're going to leave it at that. Y'all have a wonderful night. We'll catch you next time, and we'll see where we are. I think this kind of finishes up. I think the next thing you'll see on this is me letting you know that the plans are. The plans I will. So we're in July. So the plans will be free to download in the video description. For probably a month or two. And then after that, they'll go up on the website for a digital download and a fee. All right, everybody. Y'all have a wonderful evening. That's where we're going to leave you for tonight. And we're going to, let me get back to here. But when it's all said and done, maybe next time or something, we'll talk about these parts. But I think we're kind of over the poker table right now. I think the next thing is just watching for the actual build videos, because this will be a project that I will build. And then you'll really get to see a step-by-step and everything. All right, everybody. Looking forward to seeing what you do. If you ever do anything like this, it's going to take just a little bit to kind of put all the instructions together. And then once that's done, then I'll have them out for you. All right, everybody. Until next time, we'll catch you later. Y'all have a great evening. See ya.